All right, we're going to go over the review sheet for logarithms and make sure we understand some things. And so first step is goes from exponential form to logarithmic form. And so when I look at it in exponential form, the base is 4. And so when I start writing it as a log, I know it's going to be log base 4. All right. The exponent goes outside and the 4096 goes here. And so that is just how I switched the form from exponential form to logarithmic form. And that one was choice C. There's two ways to do number 2 and 3. Change of base is probably the easiest one as far as you can do on every calculator. You hit log 4 or 64 divided by log 2, log of the bigger number divided by log of the smaller number. It's called the change of base formula. It works in every calculator. Now, sometimes you have to hit log 64, close the parentheses, and then hit divided by log 2. All right. If you're using a graphing calculator in class, you can hit the math button, and then you're going to go up until you hit log base. And you hit that log base button, and it will be able to type it in just like it looks. And you'll solve it, and you'll get the answer is D6. And so for number 3, you're going to do the same thing, except for you're going to use log 56 and log 7, log 56 divided by log 7, or hit that log base and type it in. Okay? And you get 2.0686 to the nearest 4 decimal places. 10 thousandths is 4 decimal places. For number 4, it's log base 5. Log base 5, power of x. Okay. If it was log like 1/5 or some fraction smaller than 1, this would be decay. It would be going down. This one's positive 5, so it's going up. So I know then it has to be either B or D. The plus 5 tells me it's up 5, not at its normal place. And so it's either C or D, because those are the ones that are moved up. And so my answer for this one has to be, or is, I should say, D. Now, if you're really struggling as to why did I say it moved up, instead of being at the point this point right here at 1, 0, it is now up here at 1, 5. All right, so it moved up 5. Number 5, I have to switch it from log form to exponential form. So it's base 16 to the 5/2 power equals x, which 5/2 is just 2.5. Might be easier to plug into your calculator that way, but just do 16 and hit the little rooftop looking button, caret button, and type in 2.5 as the exponent, and you get 1024. They're both in number 6. They're both log base 6, so it's like they cancel out. And so I have 7x equals x squared minus 44. I need to get it to solve a quadratic. I need to get it equal to 0. So I minus the 7x rather over. And now I need to factor x squared minus 7x minus 44. I need to factor it up. X and x makes x squared. What numbers? Multiply to make 44, but subtract to make negative 7. Multiply to make 44, but subtract to make 7. Right? And that would be 11 and 4. Now it's negative 7, so the bigger one's negative. And it still equals 0. Right? So now I set them individually equal to 0. I add 11 to both sides. I subtract 4 to both sides, and so my answers are -4 and 11. Number 7, we don't have one on the test like 7, but I did want you to think it through. And so if you could determine 6 to some power makes 3072, if 6 to some power or exponent is 3072, yeah, then you could approximate a value. Number 8, x is an exponent. How do I solve it when x is an exponent? X is up high as an exponent. I have to get it down, which means I log both sides. Log both sides. The whole point of logging both sides is that now you can put the 2x down. So I divide by log 9. And I divide by 2. Right? And so let me break this up a little bit. So I'm going to take my calculator because that's too much dividing by my screen. So take my calculator, log 87 divided by log 9. I get it's about 2.0325. And so now I divide by 2, and I get 1.0163, which is choice A. Number 9, you would log both sides. Log to get the x down. So now the x comes in front. You divide both sides by log 15, so you get x equals log 70 divided by log 15, which is choice B. Use a calculator, type that in, log 70, close the parentheses, divided by log 15. Nearest 10,000 minutes is 4 decimal places, so you get 1.5688. Number 12, when you're adding, you change that to product property. So adding means you multiply. So it becomes log 2 of 20x equals log 2 of 40. And then they're both log base 2. So it really just is 20x equals 40. So x equals 2. For number 11, the y, the variable is up high. So to get it down, I have to log both sides. I pull the y down. I now divide both sides by log 7. So I got log 15 divided by log 7. And so y equals, or I should say approximately, 1.3917. Same thing for number 12. The y is up high. So I log both sides. Oops, I was going to put equals. It's not equal. It works just like equals, but it's a greater than sign. And so the y plus 4 goes in front, and you're going to divide the log 8 over. Right? And so, again, I'm just going to take my calculator and do the work. I get that is like 1.30229. I minus the 4 over. I get y is greater than negative 2.6977. If I just look at the first one, e to the power of 9 equals 4x. If I think about logging it, then it's going to be log base e equals 9, and 4x goes here, and log base e is just ln 4x equals 9. Right? And so that one right there is b, right? Which means this one would just be ln 9x equals 4. Right? Which is D. And this one would be ln 9 equals 4x, which is C. And this one would be ln 4 equals 9x, which is A. 14 is use the properties. The first one, they got a number in front, so it's the power property. So you're going to put it as the power or exponent. Well, 36 to the 1/2 power is saying the square root of 36, which is just 6. And now I'm going to work from left to right. And so I get ln 6 divided by 7, because minus becomes divided by. And I'm going to times that by 35. And I get ln 35 times 6 divided by 7 is ln 30. Fifteen, Mark took 200 milligrams of medication. The function f of t equals 200 times the natural base e to the power of negative 0.4 t can be used to determine the amount of medication f of t still is in his system after t hours. To the nearest hundredth, after how much time will Mark only have 50 milligrams of medication left in his system? And so they gave us the whole equation. Right? They gave us this whole thing, 200 e negative 0.4 t. But they want to know how long is it going to be time until it reaches 50. And so the first thing I have to do before I can log both sides, I have to get the e by itself. So I have to divide by 200. So I divide both sides by 200. 50 divided by 200 is 0.25. 0.4 t. Now I can ln both sides. So now I get ln 0.25, sorry. ln 0.25 equals negative 0.4 t. I divide both sides by negative 0.4. Right? And I get t is about 3.47. So it's 3.47 hours. In 2016, there were 5,508 landlines in a town. That same town, though, in 2004, had 11,124 landlines. Continuous exponential decay for the number of landlines is y equals the initial amount. Which of these is the initial amount? All right. Well, 2004 comes before 2016. And so this is the initial amount. And it's decay, so I know it has to be one of these ones with a negative. And then they're both 0.59, so they're trying to distract you with that. So right now they're like saying winner, winner, chicken dinner right there. And so that is my equation. Oops, let me fix that. That is my equation. Y equals 11,124. Right, E negative 0.059 t. And for this one, it says landlines fewer than 1,000. So you're going to plug 1,000 in here. divide by, let me switch to a smaller lead size here, 1,000 divided by 11,124 equals E negative 0.059t. Now, I will ln both sides, or log both sides. It's ln because it's E. Right? And so I get ln of all that stuff. Equals negative 0.059t. And so I divide by that negative 0.059, divide, and I gotta see, can I use a calculator? And if I do, I'll get a positive, and it's gonna be 40 point something years. And so 40 point something years after, so it's 40, I got 40.83, right? So 40.83 years after 2004. So 40 years after 2004 would be somewhere in the year 2044. All right, test coming up. Please be ready.